Hey there, ladies and gentlemen, boys and girls. Today we're going to talk a little bit about predator-prey relationships. We got our predator, vicious predator, and our poor little prey here. We're going to talk about the relationship between that we find those in an ecosystem or between two populations. Most of the understanding of predator-prey relationship, especially for what we're going to be talking about in this in biology, is pretty intuitive. All right, you have to understand this is all predator-prey relationship is literally a competition for energy. Right, all organisms are looking to take in energy. Right, whether it's the Officer Hops who is looking for energy from producers such as like carrots, or whether it's Mr. Fox who is looking for the energy by getting his energy from Officer Hops. And so, it's just about a competition of energy. And it's actually a very delicate balance between predator-prey relationship. Just a few things can completely alter that relationship and change one species or both species for the better or for the worse. And so to do that, I want to go show you guys a little simulator here to kind of talk about that. And then what we're really going to focus on is what it looks like going forward. All right. So I have a little simulator here. I really like this simulator. It's very low res, obviously. But what we have here is we have different patches of grass in the green. We have these little here. These are the rabbits. And then we have here we have different wolves. All right, so we're going to do the relationship between not only grass and rabbits, but then rabbits and wolves. It's all about transferring energy and doing it. All right, to get the best results, I'm actually going to switch this to a large one. And so I'll kind of make this kind of go forward and back, and then we can actually look at the end of it. We can look at a little graph here, which I'll zoom out when we're ready, to kind of look at how each one of those populations did in this scenario. All right, so let's go ahead and try this once. We might have to do it once or twice because it is kind of random, and sometimes it shows everything I want to see, and sometimes it doesn't. So let's just try it first time here. So the rabbits are going to eat the grass. All right, the grass will grow back, and then obviously the wolves will eat the rabbits. All right, so as the rabbits eat more grass, their population is going to increase. Well, the wolves now have a surplus of food to eat. All right, and now the rabbits have less grass to eat, and now there's a lot of them, but now there's lots and lots of food for the wolves. And so the wolves, as you might expect, rabbits can't eat grass, but there's lots of them, so the wolves are going to do very well. Grass starts to return because there's less rabbits. The population of rabbits, now low, is going to do better because look at all this grass. As the rabbit population starts to increase again, is low, that's less food for the wolves. And so the wolves population starts to go down again. But now the grass population is starting to go down because there's more rabbits eating them. All right. Oh, here comes the wolves. Barely a few of them, but look at all these rabbits to eat. So the wolf population is going to do very well. And so we're getting this up and down between these couple species here. And that's exactly what we want to see here. All right. I think that's enough running it for right now. So let's kind of zoom out a little bit here so that we can look at the graph and see how they did here. All right. Now, because the wolf population doesn't ever get very, very big, it's kind of hard to see it a little bit. So we'll talk about a couple things. Let's talk about the wolf and rabbit relationship here. So rabbits being the prey and wolves being the predators. All right. You notice here as we see a spike in the prey population, right after that, we see a spike in the predator relationship, the predator population. As the prey population decreases, though, right, and it's kind of low, that's less food for the predator. Their population's going to go back down. All right, and you're going to see this kind of almost like two waves, but not on top of each other, kind of almost off sync. We could see this as well. In this case, we could say the grass is the prey, and the bunny or the rabbits are the predators, because they are getting their energy from grass. So we see a spike in the grass, followed by a spike in lots of grass, which means lots of rabbits to eat it. All those rabbits eat all that grass. There's a dip in the prey relationship, or prey. As the predator goes down, prey goes back up, and you see that their cycles are just kind of slightly off from each other there. All right, this is what we would typically see with a predator-prey relationship, is a graph that kind of looks like this. This is kind of nice, clean data to look at. All right, where there's the offset predator and prey, the blue being rabbits or prey, and in this case, the orange being wolves, the predator. All right, as one's population goes up, kind of delayed behind it, you're going to see the other one's population go up, and one goes down, the one afterwards is going to go down. So like, if we just look at just this generation right here, all right, the wolf population is doing really, really well, but all those wolves are going to eat more rabbits. So in the following couple generations, the rabbit population's getting eaten by a ton of wolves. And at this point here, the lowest point for the prey, the rabbits in this case here, there's not that many foods. And so we're going to have wolves starving. We're going to have starvation. All right. And so those wolves that wolf population's going to go down. And then down here, when there's less predators, there's a lot more factors. That's one factor that's going to stop, or that's going to allow the prey population to boom. All right. So I feel like I'm repeating myself here. It's pretty intuitive. Now, this relationship is very fragile, though. All right. And I can show that by kind of doing the simulation again, but just adding, I can change a couple things here. So let me reset this here. And you know what I'm going to do? I'm going to modify, what do I want to modify? Let's say, all right, let's modify the wolves. Let's say there's a mutation. All right, there's a mutation in the wolf population, and they're able to metabolize their food better, which means they don't need as much wolves to eat, or as many wolves don't need as many rabbits to eat. Let's say their metabolism even just goes down to 90. So that's a significant one, but it's not like it's cut in half. All right. Now the wolves need less rabbits, right, to reproduce. Like they don't need to, or so let's see what happens in this case here. Let's get this nice and ready. All right. So obviously they were kind of as like last time. The rabbits are gonna eat. Let's get it going a little bit more. All right, rabbits are gonna eat. Wolves are gonna come in. All right. Now there's the big bunny population. The wolves are going to come in, except now they're going to do very well. Look at all those wolves. All right. They're going to do very well to the point where I think they did. I think they ate all the rabbits. They ate all the rabbits, but that means they have no food, which means the grass is doing really well. Look at that. All that was a slight mutation. Look what happened to our curve. Right, as we expected, rise in the rabbits, followed by rise in the predator. But the predator did so well because of this mutation that they overate, and they caused the rabbits to become extinct, extinct from this area, followed by no more food for the predator. So as much as there's this relationship, and the only one who really won out on this is the grass. All right. So it's a very delicate balance here, all right? But basically understanding this relationship, it's a very delicate relationship. If we end up having, if we hunt all the rabbits, the wolves are going to die out. If we hunt all the wolves, all right, let's try that one. Let's say we get rid of the wolves. Let's start with, let's reset the simulator. What happens if we get rid of the big bad wolves, right? Because I want to protect my precious little bunny rabbits. All right, let's set this back to 120 just so that we can kind of keep that the same. But this time, we're going to say that there's no wolves. Let's say we hunt all the wolves. All right, because I love the cute little rabbits and I don't want them to get hurt, right? So if I start the simulation, All right, the rabbits are going to eat the grass. They're all living very happy. Look at all this grass that's getting eaten. Bunny population's doing very well. Bunny populations. Oh wait, where are those wolves coming from? There's not supposed to be wolves. How was that? How there's supposed to be wolves? All right. Well, that was a fail. Let's think about it. Wolves all, or if there's no bunnies, they're going to eat all the grass, and once all the grass is gone, there's no food for the rabbits, and they're going to go extinct. So, kind of a fail on my experiment there. All right, tried that on a whim. All right, so recap. There's just basically this delicate relationship between predator and balance. It's kind of this off, or predator and prey. There's this off-shifting graph. And understanding the relationship so we can predict what's going to happen next. So at this generation here, I can guess that the bunny population is going to go up and we're going to actually start seeing more wolves around as well. All right. Other than that, that's basically covering that major concept. Otherwise, if you have any questions, make sure you message me, and good luck, and may the science be with you.